Thesia, hello. How are you? Good morning, good afternoon, good evening. To start, let's get our cup of coffee, which is a must. And we begin with solving the first exercise on this channel, an integral exercise. We are here to support you, and to resolve any doubts, I will make notes and hope it becomes as clear as possible. In this case, the integration part, we will start with a simple integrand. We have the integrals x by dx. Case, I am going to rewrite it in this other part to point out certain elements that are necessary. Very well, we have the integral of x dx. In the integration part, it is essential to have certain elements. It is essential to have the integration symbol, which is more than obvious. It is necessary to have an integrand. In this case, what we are going to integrate in this case is x, and the differential part. What is the referential? The differential is that derivative of what we are going to integrate. Well, what we are going to integrate is x, and the derivative of what we are going to integrate has to be the differential, or is the differential. In the section on integrals, two common terms are used that you will be able to observe in the various forums that are available, whether on the internet or in textbooks. This part is you and do. What is u and what is do? U is the part we are going to integrate. U is this part we have here, which in this particular exercise is x, without taking the exponent, of course. Very well, in this particular case, our u is x, and that do I mentioned to you is the derivative of what we are going to integrate. And if what we are going to integrate is in x, then we need the derivative dx. The derivative of x, we all know, is 1 times dx. But for simple purposes, you know that when we have a number 1 in some function, in some operation, we know it's there, we know it exists, but we don't write it down because it's unnecessary to do so. In this case, we would have that the derivative of x would simply be the x. And it is in this part where we have to observe if we have these two elements within our integral, if we have this part here and this part here. If we have these two elements that are essential for integrating, then we can proceed to see which method we are going to use to integrate. We observe the equation we have initially. Do we have x? Yes. Do we have dx? Yes. In this case, we have the two essential elements to integrate. We have them complete. We have our do, in this case dx, complete the complete differential. Later, we will discuss some rules, one of which is that we can complete that differential if it is not complete. And we can complete it with numbers, but not with variables, not with letters, nor with the trigonometric part either, not trigonometric functions either, neither sine, nor cosine, nor tangent. We can only add numbers, but later we will explain it. In this case, we have it complete. We have that our deal is dx, here it is, and our u is x. Perfect, it's complete. As you know, in every universal rule, we always start with the simplest, and it is the most obvious, the most objective, and the most efficient. The simplest, what is it? The simplest method of integration is one called the chain rule. Here I am going to show you chain rule. What does this chain rule tell us? It mentions that if we have a u and we have a do completa, if we have our do, which is the derivative of u and is complete, or if we can complete it with some number and at this particular moment we have it complete, we can proceed to use this rule that tells us that if counting, already having a u, un plus 1 over n plus 1 is the form of the solution. You might be wondering, what is n? Where do I get it from? I see that it is the exponent of u, but where does it come from? If we have that ru, we had said, is x, our n is the exponent of that x. You can tell me what exponent we have here, and it is raised to the exponent 1, which is the same as if we had x to the 1. In this case, our n is 1. Perfect. Now, the formula or the chain rule tells us that it is u to the power of n plus 1 over n plus 1. Let's proceed to perform this operation. Our u is x, our n is 1 plus 1, which is what the rule indicates. And we are going to divide by n, which is 1 plus 1. As the rule indicates, this would leave us with x squared over 2. And always, you can remember, always in integrals as a rule, you have to add at the end a plus the constant of integration. We exemplify this constant of integration with a c. Perfect. In this case, this would be the solution to our first integral exercise, using and applying the chain rule, ensuring we have the essential elements to integrate, and especially to apply the chain rule. We have the part, in this case our u, we identified it, identified our du, we saw that we had it complete. In this case, the chain rule, we saw that we needed a u and a do. We have both, we have all the elements to use it and simply substitute. That would be all for the first exercise on the integrals channel. I'm here for any questions you may have. If you need any guidance, check the information below the video and we can gladly schedule a session to address any questions you might have. This channel is dedicated to that, to solving exercises so that you gradually develop the ability to solve them and identify those essential elements and the most efficient method to solve the exercise. Take care, be well, have an excellent day.